Okay, so today we're going to talk about fractional equations. Okay, this is really similar to what we did last time, except now on the denominator, instead of just having numbers, guess what we're going to have? Variable. So there is a definition. That's the only difference. So, fractional equation is nothing more than an equation with a variable in the denominator of one or more terms. Okay, that's all it is. So write this down. So if I have a fractional equation, what did we do last time? We had fractional equation last time too, just didn't have any variables on the denominator. What do we need to do to get rid of all these denominators? Yes?
We multiply by the LCD.
Yeah, guess what we're going to do for these? When with the variable. Multiply both sides by? LCD. And guess what the LCD is going to contain? Yeah, that's right. So that's exactly the same thing. We're going to do the same exact thing. We're going to multiply both sides of the equation by LCD to get rid of all the denominators. But this time, the LCD will contain some variables. And something interesting happens when you do that. Okay, so I'm going to explain that in a minute. It is really similar to what we did last time, except there's certain things we got to be careful of. Okay. So must multiply both sides by LCD. Let's look at our first example then. So here, 3 over t minus 1 over 2 equals to 1 over 10. As you can see, unlike last time, we have a variable, but it's nothing really, to worry about. Oh, but as soon as you have a variable in the denominator, do you guys remember something called restrictions? Okay, we kind of have to think about restrictions. Okay. What is the restriction for this one? Yes. T cannot equal to 0. So I'm going to actually kind of put that in there to kind of remind myself, okay, t can't be 0, okay? Because if it was, then this whole, that fraction would be undefined, you know what I mean? So you can't really solve this. So I'm going to kind of, so that's one of the things that happens when you have a variables in the denominator, you get restriction. And not only that, there's some other thing. Anyway, we'll get there in a minute. So what is my LCD for this? First of all, I have three denominators, t, 2, and 10. My LCD is going to be, Alvin? 10t. So guess what? I'm going to multiply both sides by 10t. It's really 10t over 1. So my LCD is 10t, as you said. Multiply both sides by 10t over 1. And what do we get when I do this? Andrew, tell me what I get on the left side.
You got 30t over t.
Which is going to be? Well, yeah, let's just write it. Okay, you get 30t over t minus?
Minus 10t over 2.
Equals to?
10t over 10.
Yeah, so, oh, actually I did write that down. Okay, Andrew said when I simplify this, good, what do I get? This whole thing just simplifies to?
30t.
30t, are you sure? Well, don't the t's cancel out?
Oh, yeah.
Yeah, so you get
30.
30
Minus 10, 5t.
5t
Equals t.
t, that's exactly right. So this whole equation, this fractional equation, just simply becomes 30 minus 5t equals to t. Isn't that right, guys? Okay, do we know how to solve this simple equation? Yeah. All we have to do is add 5t to both sides. Then you get 30 equals to 60. Divide both sides by 6. T equals to 5. That's it. We're done. Not quite. We had to. Well, okay, hold on. So, do we need to write down the restriction? Not really. When you're solving, okay, think about this. When you are solving, we wrote these restrictions when we were simplifying expressions, right? We're saying that expression cannot have something, But when we're solving it, when we get the answer t equals to 5, what does that mean? Everything else doesn't work, right? That's what we're saying. So you don't have to say, oh, by the way, what was our restriction? T can't be 0. You don't need to say that because, we know that t isn't our solution. You know what I mean? But restriction will come into play if the answer that you get is the restriction. So this time we got t equals to 5. What if this came out to be t equals to 0? Guess what? That happens to be a restriction. right? So therefore, guess what? You cannot, you no solution. You can't use that solution. So that's the thing that's the why. So you don't write down the restriction at the end. You just write, I wrote it in the very beginning, right? If your answer happens to be the restriction, you can't use that answer. Does that make sense? So just kind of keep that in mind. Also, there's another thing. You must check the answers when you're solving fractional equations. In other words, when you are multiplying both sides by some variable. So far, we haven't done that, right? We only multiply both sides by some number. When you multiply both sides of an equation by a variable, you must check the answer. You must. Because, can somebody guess why? Yeah? Because you may be introducing more solutions to the original equations by multiplying both sides by a variable. Okay? Does that make sense? So when you multiply both sides by a variable factor, okay, a factor that contains a variable, you may be introducing more solutions than from of the original equation. So you got to check. Okay, sometimes you do this. Sometimes you get an answer. It doesn't work sometimes when you multiply both sides by a variable. So that's why when you have fractional equation, you have to check. Okay, so how do we check? Plug in 5 to the equation, and I checked it. It comes out to be true. Okay. So sometimes when you multiply both sides by a variable, like I said, you may be adding some more solutions that original equation didn't have. Okay. So you got to check and see if it works. Okay. So that's why the fractional equation you got to kind of be careful. You got to check for the restriction, right? By the way, as you're checking, right, you know that restriction won't work because it'll make the denominator go to 0. So that's why when you check, you won't know. But it's kind of nice to kind of know in the beginning. Yeah.
What if it doesn't work? Like when you check?
Okay, very good question. What if we did this, right? We got 5 as our answer, right? And we plugged it in. It didn't come out to be true. Guess what that means?
It's wrong.
No. Well, okay, let's say that you checked it correctly. That means, and you did everything right?
Yeah.
Yes, that means?
You have to see if you're probably LCD is not correct.
No, not necessarily. So even if we did the LCD correctly, what I'm trying to say is, remember I just said if you multiply both sides by a variable, you may be adding more solutions that didn't belong in the very first place. So guess what? If when you check and if it comes out to be false, that means you have no solution. That number is not part of your solution. Okay? We'll see some of those in a minute. But yeah, so that's why it's really important to check the answer. Okay, when you check it, you will know for sure whether it works or not. Like I said, it could be that you have added additional solution that didn't belong to the original equation. Okay. Anyway, all right, let's go to example. Here's example 2. We got n plus 1 over n plus 2 minus 10 over n squared minus 4 equals to 0. This one looks a little bit different than the previous one because look at my denominator. N squared, especially the n squared minus 4. Alwyn, what do you see? Actually, someone else. Yeah. Yeah, it's a difference of square. Do you think we should factor the denominator? Yeah. The reason why we need to factor is, first of all, what does it become when you factor, Andrew?
N minus 2 n plus 2.
That's right. So you must factor the denominator. The reason is because it helps us to figure out the LCD, and also it helps us to figure out the restrictions as well, right? If you don't factor the denominator, you don't know what the restrictions are or the LCD. So it helps us in many ways. So let's write down our restrictions, okay? So if we happen to get this restriction as our solution, you can use those, right? So what can we not use as a restriction here? Emily? Is that it? Negative 2 only? Yeah, there are 2 restrictions for this. N can't be 2 or n can't be negative 2. Right, Lara? So, and what is our LCD, Lara? Yeah, n plus 2, n minus 2. Now that we factor out our denominators, it's basically product of all the unique factors with the highest exponent. Well, all the exponents is 1. So, you're right. It's n minus 2 and n plus 2. So guess what? We're going to multiply both sides by the LCD. Okay. Everybody go ahead and try and see what you get. I'll give you some time. So let's see. Let me pick on someone I haven't called. How about Anais? What do I get when you multiply both sides by just LCD? Equals 0. Okay, and when you simplify that, what do you get? What cancels out and so forth?
N plus 1, n minus 2, minus 2, minus 0.
That's right. And did you say n plus 2 or n minus 2? Isn't it n minus 2 times n plus 1?
I said n plus 1, n minus 2.
Oh, okay. You said, okay, that's the same thing. Okay, n plus 1 times n minus 2 minus 10, right?
Yeah.
Equals to 0. Would you all agree? Okay, now, how do we solve something like this? Madeline? Yes, you multiply these two binomials together. Okay. How many of you guys got this? Well, after you simplify n squared minus n minus 12 equals to 0. Raise your hand. Okay, if you're not there, please fix it, because this is where you need to be. If you didn't, okay, take a look at it. Help each other out here. Colleen, did you have a question? Oh, you got it? Okay, very good. Now, okay, there's some groups that's still working on this. Okay, now listen. Kobe, you need to pay attention. Okay, now, what kind of equation is this? Is this a linear equation?
Yes.
No, it is not. Okay, linear equation is, linear equation is where you have something to first power only. This one has n to the second. So what do you do this? How do you solve equation that is not linear? Savannah? You need to factor. You have to use this property called? No, it's not factor property. What is this property called? Whenever you have equation that is not linear, you must use this property to solve. It's called, yes, something product property. No. Zero. That's right. Chance is correct. It is called zero product property, meaning you have to be able to factor the left side that equals to 0, because then we know what makes the whole thing equal to 0. Remember? That's going to be important. So, do we know how to factor this trinomial? Okay, what does it factor to? How about Shrock? Oh, Lindsay? N plus 2 times n minus 4. Wait. So you mean 3. Okay, good. Because we're basically looking for, you guys remember how to factor this? Right? We're looking for two numbers. Then when you multiply, you get negative 12. When you add, you get negative 1. Negative 1, right? Not negative n, negative 1. So you're right, Kyle. Then what makes this whole thing equal to 0? This is only true if what?
If you like make one of the things in the parentheses equal 0.
Yeah, one of the factor. So this is only true if what? What is one of the thing in the parentheses?
N equals 4.
Yeah, n minus one of the factor, right? So this is only true if n minus 4 equals 0 or what? N plus 3 equals 0. And there are two possible ways for this to happen. How many of you got negative 3 and negative 4 as your answer solution? Good, raise your hand. Negative 3 and 4, I'm sorry. Negative 3 and 4, good. Good. Now, am I done? No, you must check, because like I said, guys, you must check because it could be one of your restrictions. Or was it? So it's a good thing that we figure out our restriction. Was it one of our restrictions? No, so we're good with that. But like I said, as we multiply both sides by a factor that has variables inside, we may be adding new solutions that didn't belong to the original equation. So you have to check. Did you all check? Look how I checked it so nicely. Look, I checked it really. I wrote down the original equation. I plugged it in nicely. Okay. They all work, don't they? Okay. So yes, you have to check. Otherwise, sometimes some of these may not be your solution. Like that's the price we pay when we multiply both sides by the factor with the variable, because you don't know whether you're adding a new solution or not. That didn't belong to the original. So negative 3 and 4 is your solution. Question? That's right. If none of them works, no solution. What if only one of them works? Then that's the only one. Okay. All right. Let's try then next Next one out. This is going to be similar to this. Okay. I would like you to try the next. Okay, go ahead. Try example 3. I put a star here. See if you could do this on your own. Go ahead, everybody try. Do you think you should factor out the denominator first? Yes. Okay, guys, I'll give you more time. Let's just see whether we're going to the right place. Okay, Aaron? I would like Kobe. Kobe. Okay. I want to see whether you guys are going to the right place. Okay, so first, did you all factor out the denominator this way? Yeah. Then you will know your LCD and your restriction. First of all, your restriction, there are 2. Did you realize there were 2 restrictions? X can't be 0 or 1. Okay? And your LCD is simply the product of the, well, actually the denominator the first. So when you multiply both sides by x times x minus 1, you get, things will cancel out. John, what did you get? Left side becomes? Yeah, it becomes 2 minus 2x. And the right side, of course, is 1 times the LCD, so it's the same as LCD. Did you all get it? Did you all get to this part? Are you good so far here? Malia? Tell me, what do I get here? What should I do? Oh, you want me to factor out? Okay, so you know, a lot of people are doing this because we've dealt with this sort of questions a lot, right? So a lot of people factor out the left side and wrote this as 2 times 1 minus, what is it? X equals to x times x minus 1 and so forth. And then you factor out a negative 2, right? So it becomes that, and then did you divide both sides by x minus 1 or something? Guys, let me tell you right now. Do not divide both sides by... No, do not. So a lot of you did this, okay? So actually, let me write this down. So a lot of you... Yeah, I know. So some of you from here... Let me move this over here. So some of you did this. Listen, guys. Hold on. Hello. Some of you did this, guys. Some of you factor out a negative 2 from this, and you get negative 1 plus x, right? Equals to x times x minus 1. Guys, listen. And then you get x minus 1 times negative 2 equals to x times x minus 1. And then you factor out both sides by... Don't divide both sides by x minus 1. Do you know why? Yeah, don't do that. When you do this, whenever you have equations and if you divide both sides by a variable or factor that contains a variable, you may lose one of the solutions of your answer, of your equation. So please don't do that. I know that a lot of you guys looked at the common factor, try to divide both sides by x minus. Don't do that because you will lose one of your solutions. Did you all hear me? Okay, so please don't do that. Then how are you going to solve this? If you can't do this, you don't want to divide both sides by a factor that contains a variable? Yeah. Yeah, multiply the x's together and just simply make the whole thing equals to 0. This is the way that you should be doing it. Okay, so please, guys, like I said, you don't want to, if you do this, you will lose one of your solutions. Okay, so make sure you do this correctly this way. Okay, and you get a trinomial that equals to 0, then you want to use the 0 product property, you factor. So what 2 numbers can you multiply that equals to negative 2, but when you add you get positive 1? Yes, sir?
1 and negative 2, but you can't use 1.
Hey, hold on, so yeah. So this factors as what? Doesn't this trinomial factor as 0 equals to x plus 2 times x minus 1? Okay, and this is, hold on, this is only true if what class? X equals negative 2 or? Now, how many people wrote down as t negative 1 or 1 as your answer? Yeah, you have to check. By the way, so even before you check, because we wrote down our restriction, one of these numbers are? Wrong, because one of them is a... Yeah, look, go back. If you go back, our restriction was what class? 0 or 1, and guess what your solution is? You have to drop that one because that's your restriction. So your answer is what, class?
-2.
-2. Am I done?
No,
No, you must also plug it in. So, guys, listen. Here's what I'm trying to say. The reason why we wrote down the restriction at the very beginning, guys, is if you knew that one, you don't have to plug it in and check. If you didn't know, then you would, as you check, you will figure out. See, it'll, you have to actually plug it in and check, which would, right, cost you some time on the test. Does that make sense? So it's nice to know what your restriction is in the very beginning, so that when you get one of your answers as a restriction, you don't have to even check it, right? You don't even. Does that make sense? So then you check the other one. Does it work out? If you plug in -2, guys, there's my check, and it does come out to be 1. Okay, 1 equals 1. So it does work. So this is your solution. Any question? Okay, so you write x equals 2. And then look at what's inside on this bubble. Okay, watch this. Some of you, again, another explanation is if you try to divide both sides by a factor that contains a variable, look what happens here. If I happen to have 0 equals to x plus 2, guys, listen, times x minus 1. If I divide both sides by x minus 1, well, left side will be 0. So you're left with 0 equals to x plus 2, right? And why don't we then divide both sides by x minus x plus 2? Then you get 0 equals to 1. So this isn't true, right? You see? So you don't want to be keep on dividing both sides by factor that is a variable. Yes, Emily? Oh, okay, hold on. Guys, will the solution be always 1? The answer is no. Okay, sometimes you have 1, sometimes you have 3, sometimes you have a lot more. Yeah.
What if you do that, but instead of dividing x plus 2?
Hold on, guys, I can't hear. Hello? May I have attention? Okay, sure. Yeah, this is not the time to ask questions. I understand, but you need to ask me the question, because you know why? If you do that, then we can't go on, right? I can't hear other people's. Okay, so what was your question?
So like, okay, so you did that, right? But then instead of dividing by x plus 2, you subtract 2 from both sides, and then you get -2 equals x, that's right.
Right, but what if I just decide to, but we don't want to talk about, see, this is how you lose your solution if you keep dividing both sides by the factor that contains the variable. Does that make sense? Okay, then let's go on to the next example. Here's example 4. Everybody try this one. Emily, you know that question that you asked, whether or not do you always get just one answer? This will answer that one, okay? So, example 4. 3y minus 6 over y minus 2 equals to 3. Looks very simple. Go ahead, everybody try. See what you get. Okay, I hear a lot of people saying, oh, all real number as a solution. How many people got all real number as a solution? Raise your hand. Okay, a lot of you. That's wrong. All right, hold on, guys. All right. Okay, hold on. Shh. Listen, may I, guys, may I show you why? Hello? Thank you. Here you go. So, I bet a lot of you multiply both sides by the LCD this time is, okay, you're, by the way, what's my restriction? Y can't be 2, right? So you multiply both sides by y minus 2, then you get 3y minus 6 equals 3y minus 6. At this point, you know the left side equals the right side. So yes, every number will work except 2. So guess what? How many people realize now that you can't just put all real numbers? You're right, it's all real numbers except 2. Oh, you did put it? How many? Raise your hand. Listen. Shh. Raise your hand. How many people put down? Okay, some of you did. Very good. Do you see? Okay, so does that answer your question, Emily? Emily, sometimes you don't always just get one answer. This time you got a whole bunch of them, right? Okay, any question? Does this make Chanzu, you got a question? Oh. Does this make sense? Yes, question? Yeah, I mean, yeah, you could factor out the 3 and then divide both sides by 3. It'll left side will still be equal to right side. So you could keep going, yeah. It'll always be true, right? You get same thing equals to the same thing on the other side. So you know at this point that it's by the way, guys, what do we call this kind of equation? Identity, right? Left side equals to. But it's sort of different because you have an exception. You can't have y equals to 2, you see? So on the test, do you think it's important to write down except 2? Very good, okay?